All right, so we're going to tackle binomial expansions and the binomial theorem both in this video. Binomial expansion is just when I have a binomial raised to a certain power, so that would be called the power of a binomial. In this case, a plus b is the binomial, and it's being taken to the nth power. And I could just expand that by writing a plus b times a plus b times a plus b, and then foiling or distributing each one and then continuing and continuing until I have n copies of that. But depending on what that exponent is, that can be rather tedious. So there's a three-step process for expanding binomials. The first is that we're going to pull, I like to call them the raw coefficients, from Pascal's triangle, which you probably have heard of. Blaise Pascal was the man attributed with this, even though he was not the first person to come up with this. I don't think so. And Pascal's triangle is made by putting ones on the outside and then by adding the two numbers above a box to get the number that would go underneath. And you can memorize some of these rows, or you can rederive Pascal's triangle every time you want to use it, depending on what row you need. The labels, so this would be the fourth row. It's actually the fifth, but we start counting at row 0, so that the fourth row would align, for instance, with the one that has a 4 in the second spot. And so that helps keep us on track. And then each element in the row is a certain element. So in this case, I would call this the second element, because just like we start counting at row 0, we're going to start at the 0th element here. That's going to help us out if we consider that we know from earlier material, probably, that the row of Pascal's triangle can be represented by n choose r, and that it would be the rth element in the nth row of Pascal's triangle. So for instance, this third row that I've circled, 3 choose 0 is 1, 3 choose 1 is 3, 3 choose 2 is 3, and 3 choose 3 is 1. So the row number is the n, and the element number is the r, but we start counting at row 0 and element 0. All right, so that's the first part of it. That would be the raw coefficients. The second part of it is that we're going to do powers of a. They are going to start at the top exponent, and they are going to descend. And then powers of b, which is the third element that or the third component that we need, they're going to start at 0 and ascend. A plus b to the n is going to have one more term than that exponent. It's going to have n plus 1 terms. All right. Also, if you have a problem that has subtraction in it, you can either attach that subtraction to the second term in the binomial, or you can simply make your second term in your answer negative and alternate signs, because a negative to any odd power will be negative, and a negative to any even power will be positive. For example, let's go ahead and look at x minus 2y, that quantity, to the 5th power. So the first thing I'm going to do is pull the 5th row of Pascal's triangle for my raw coefficients. So that would be 1, 5, 10, 10, 5, 1. Then I'm going to do descending powers of x, which is the a in this case. So x to the 5th, x to the 4th, x cubed, x squared, x, and then a constant, x to the 0, right, which there would be nothing to bother writing there. And then I'll look at this one as negative 2y for the b term. So I would have negative 2y to the 0 in the first spot, which I'm not going to bother to write. And then I'd have negative 2y to the first, negative 2y to the second, negative 2y cubed, negative 2y to the fourth, and negative 2y to the fifth. These then are my terms. In the final answer, I just need to go ahead and simplify each term and write it all out. So I would have x to the fifth. In this case, 5 times negative 2, when I multiply the coefficients, I'd get negative 10, and then x to the fourth and y. Negative 2 quantity squared, if I simplify that part here, this would be 4y squared. And so in my final answer, then I'd have 10 times 4, 40x cubed y squared. Negative 2y quantity cubed is negative 8y cubed. Be careful about the parentheses so that you don't accidentally mess up your signs or forget that the exponent goes with the coefficient as well as the variable here. So I'm actually going to go ahead and finish changing those so that I can keep myself in line. So the next term I would have then would be negative 80x squared y cubed, and then positive 80 x times y to the fourth, and then for this last term here I'd have negative 32 y to the fifth. So you can see the exponent was 5, and I have 6 terms in my final answer, and I can look and kind of see that the powers of x are decreasing, the powers of y end up increasing, and if I hadn't wanted to have tagged on that negative along with the 2y, I can see that I started with a positive term and then the signs are alternating, minus, plus, minus, plus, minus. That's always going to work out. So that would just be how to expand the power of a binomial. Sometimes we don't have to do the whole expansion. If the question is only asking you for the coefficients, for instance, of a cubed, b cubed in this expansion, then I could just think about what term would produce that and not fill in everything. So if I just think about the 2a component of this, then I'd have 2a to the sixth power, 2a to the fifth power, 2a to the fourth power, 2a to the third. That's going to be the term that I want because that's the only term that's going to have a cubed in it in the final answer. So then I can go ahead and figure out the other components knowing that that's the term I want. The sixth row of Pascal's triangle would be 1, 6, 15, 20, so the raw coefficient is 20. And then for the b part of this, I would have 3b to the 0, 3b to the first, 3b to the second, and 3b quantity cubed here. So then that term would be 20 times 8a cubed times 27 b cubed. And then careful, watch out whether it's asking you for the coefficient or the entire term. If it wants the entire term, we're going to include the a cubed, b cubed in the answer, but in this case it was just asking us for the coefficient. So I'm just going to multiply 20 times 8 times 27 and get 4,320 for the coefficient that would go along with the a cubed, b cubed term. So the official binomial theorem is just a fancy way to write what we've already done. It tells us that if I were to take a plus b to the nth power, that the raw coefficients we're grabbing from Pascal's triangle, and as we know, the coefficients in the nth row of Pascal's triangle can be written as n choose 0, n choose 1, n choose 2, etc. I don't know how much n is, so I'm just going to put some dots there. N choose n minus 1, that would be the next to last one, and then I'd have a n choose n, so those would be the raw coefficients. I'm going to descend my powers of a, just like we already talked about, so this would be a to the nth power, a to the n minus 1 power, a to the n minus 2 power, etc. By the time I get to the next to last term, that would be a to the first power, and the last term would be a to the 0 power. And then the b term starts at b to the 0, and then I'd have b to the first, and then b squared, etc. By the time I get to the next to last term, that would be b to the n minus 1 power, and then at the last term, that would be b to the n power. So this is a fancy way to write out how to expand a binomial. Please don't get thrown off by all of the notation there. It's just the same thing as what we were already doing, but a formula way of showing you that or demonstrating that. What's more useful in the binomial theorem is the formula or the thought of what would the general term be. So the general term, which we're going to call the r plus 1th term, is given by n choose r a to the times a to the n minus r times b to the r. And that would be, since we're starting with a 0 here, then that's, if r is 6, then that would actually be the 7th term. So it's the r plus 1th term. We can use this part, the general term formula, to answer a whole slew of questions. So I'm going to go through some examples of that for you so you can kind of see its usefulness. Firstly, if you were told just to find the 8th term of something, I don't want to have to think about all of the terms preceding that until I get to the 8th term. So I'm going to use the general term formula to say that the 8th term would be n, which is 16. Choose r. Well, if I want the 8th term, since I'm actually starting at 0, then r would be 7. So then I would have 4x to the n minus r power, so 16 minus 7, which is 9, and then b, which would be the negative 5 over x cubed to the r power. Then I could simplify all that out if I was required to, but in this problem it says don't simplify. So there, that is the 8th term of the expansion if I were to expand it in the order of the binomial theorem as it was presented. Also, if we run into a question like this where it's asking us to find the coefficient, like the one that we did before, when we did the problem before, we actually, drew terms, thought about which term do I need, and presented it in that manner, which is fine to do that way. But sometimes it's going to be easier to consider the general term formula. So in this case, I don't know what term number I want. I don't know what r is supposed to be, but I can set up the general term that would be 9 choose r, and then 3x squared to the 9 minus r, and 5y to the r. And then we are going to just, in this case, we're going to use inspection. So we're just going to look at this and say, what would r have to be in order that I could get x to the 6th and y to the 6th? And the easiest one probably to look at is this one that has the y to the r power here, to understand that r would have to be 6 in this case. Once we figure that out, then just go back and put that in. I would have 9 choose 6 times 3x squared to the 9 minus 6, and then times 5y to the 6th. And then I'm going to go ahead and multiply all this out, and then I'm just going to write down the coefficient for the answer. So first thing I'm going to do is 9 choose 6. In your calculator, the choose is in math. If you have a TI-84 family, it would be in the math menu. You would go over to probability and then pick number 3 and choose r and fill in the blanks that I want 9 choose 6, which is 84, times 3 cubed, so 27, and then x squared cubed would be the x to the 6th part. And then 5 to the 6th power is 15,625. And then I'd have the y to the 6th. Since I was only asked to find the coefficient, I'm actually going to erase this x to the 6th, y to the 6th. And then I'm going to have to multiply all these out. So 15,625 times 27 times 84, which would give us 35,437,500. So that's probably easier using that general term formula than to try to line up and try to find what term I'm actually looking for there. A similar example is to find the constant term. So if in a regular polynomial, the constant term is always just falling at the end. But in this case, my a has positive exponent powers of x, and my b term has x squared in the denominator, which means that that's negative exponent powers of x. And so the constant term is going to fall somewhere in the middle of this expansion. It's not going to be the term all the way at the very end. So I'm going to set up the general term formula to use as a tool to find where I can get the constant term. The general term would be 9 choose r times x to the 9 minus r times negative 3 over x squared to the r power. So you can do this one by inspection as well, and just kind of figure out what r would have to be so that the powers of x are all going to cancel out for the constant term. We can also do this algebraically though. Just extract from this general term the powers of x. I've got x to the 9 minus r, and I've got x to the negative 2r. Since this x squared was on the bottom to the r power, that would be the x to the negative 2r. And then here's the x to the 9 minus r. I know from properties of exponents that that would, if I add those exponents together, I get x to the 9 minus 3r. So that would be the x factor of the general term. And if I want it to be a constant term, then that means the x's should be not there, not present at all, which means the exponent would be 0. So I want 9 minus 3r to equal 0. Thus, r must equal 3. Now that I figured that out, I can go back in here and I can write, okay, well then that's going to be 9 choose 3. And then just to check, I'm going to go ahead and fill in with the x's, that I'd have x to the 6th there, and then I'd have negative 3 over x squared to the 3rd power. So the x to the 6th and the x to the 6th on the denominator are going to cancel out, and I'm left with 9 choose 3 and negative 3 cubed, since I'm having to apply this negative 3 to both of these terms. Let's fix that notation there. And so I end up with 9 choose 3, which I know is 84, times negative 3 cubed, which is negative 27, and 84 times negative 27 is 84 times negative 27 is negative 2,268. So that would be the constant term in this expansion. Just this last example, this is from an IB test problem for IB analysis and approaches. And it's using the binomial theorem to look at finding b and finding k, and it gives you part of an expansion. So in order to do this problem, we can look at different components of it for each piece. If I start to break this down, I can say, well, I know this term would be the 2x cubed to the 8th power, and so that doesn't really tell me anything. But the second term would be 8 choose 1 times 2x cubed to the 7th power times b over x to the 1st power. And so if that ends up, we know that that has to equal 3,072 x to the 20th. I can use that to solve for b. I know that 2 to the 7th is going to be 128. 8 choose 1 is 8. X cubed to the 7th is going to be x to the 21st, and then the x to the first power on the denominator just simply creates the x to the 20th. I'm not going to concern myself with that. And so 8 times 128 times b has to equal 3072. 3072 divided by 8 and divided by 128 gives you that b must equal 3. Secondly then, I'm going to go ahead and fill that in up here, that b would equal 3. For the second component of this problem, part B, it says to find k. Well, k is just the coefficient of the constant term, which we just did an example of. So we know that we can do that by setting up our general term formula and then figuring out what r would have to be so that all of the x's are canceling out. So I'm going to go ahead and set that up. That would be 8 choose r times 2x cubed to the 8 minus r power times 3 over x to the r power. And you can eye it in and do it by inspection if you want, but I'm going to go ahead and extract the x's from that and figure this out algebraically. That this would be x to the 24 minus 3r here. I'm going to multiply those powers. And then I would have x to the negative r here, which that's going to be x to the 24 minus 4r power. So if this is a constant term, then that needs to be 0, which means I want r to equal 6. So I would have x to the 0 power. Then knowing that, I'm just going to substitute that back into this purple setup that I've already made. So I would have 8 choose 6 times 2x cubed to the 8 minus 6, and then times 3 over x to the 6th power. I can just look and inspect and make sure that I would have x to the 6th on both the numerator and denominator, so those would go away. 8 choose 6 then, if we use our calculator, or we can look at Pascal's triangle if you want to figure out 8 choose 6 that way. But 8 choose 6, let's see, is going to be 28. And then 2 times 2 squared times 3 to the 6th power, which is 729. And so 729 times 4 times 28 equals 81,648, which would be the constant term in this expression. The expansion of this would have 9 terms because the overall power was 8. So there would be 9 terms in the expansion, and the constant term in the expansion, because I had an r value of 6 here, that would actually be the 7th term out of the 9 terms if I were to expand the whole thing, which I think you'll agree with me that we don't really want to have to expand the whole thing. So this binomial theorem, hopefully you enjoy it as much as I do. Good luck on your binomial theorem practicing.